Good day. This is Module 2, and I have here the lesson about vector projections. Let's have the definition of vector projections. It says here, let U and V be non-zero vectors. Moreover, let U equals W1 plus W2, where W1 is parallel to V and W2 is orthogonal to V. So as we can see from this figure, we have when theta is an acute angle and when theta is an obtuse angle, we have here the two vectors u and v, and we have here w1, which is parallel to your vector v, and w2 is drawn orthogonal or perpendicular to vector v. So that we can also denote now vector u as the sum of the two vectors here, which are w1 and w2, as we can see from this definition. So with that, we can also see from here that when angle theta is obtuse, we have here now your two vectors, u and v, having this angle theta, and that w1 now is drawn on the opposite of vector v, but still w2 is perpendicular or orthogonal to vector v. And with that, we call now W1 is called the projection of U onto V, or the vector component of U along V, and is denoted by W1 equals projection of U onto V. Then W2 equals U minus W1 is called the vector component of U orthogonal to V. Then we have here the vector projection of U onto V is the vector projection of U onto V, that is proj U V equals quantity U dot V over the magnitude of V squared times V. Then the scalar component of U in the direction of V is the scalar magnitude of U times cosine theta equals U dot V over magnitude of V equals U dot V over magnitude of V. So this figure here also illustrates the figures that we have a while ago. So let's have this example. Find the orthogonal projection of V equals I plus J plus K on B equals 2I plus 2J. And then find the vector component of V orthogonal to B. So these are the formulas that we're going to use to find the orthogonal projection of V on B. So we have here projection of U onto V equals U dot V over magnitude of V squared times V. Then finding the vector component of V orthogonal to B, so we're going to make use of the second formula here, which is W2 equals U minus W1, which is called the vector component of U orthogonal to B. So let us now get the product of these two vectors, V and B. Because it says here the formula that we need to find the product as well as the magnitude of your vector B. So let's now have the product of these two vectors. So we have it as, so let's define the component of your vector V. We have it as, in bracket notation, 1, 1, 1. Then the other vector, which is vector B, we have it as 2, 2, 0, because we have here 2i plus 2j. So there's no k. So that means it is 0 for the third component of your vector B. So let's now find the dot product. So v dot v equals 1 times 2 plus 1 times 2 plus 1 times 0 equals 4. And let us get also now the magnitude of your b. So the magnitude of your b, which is now equal to the square root of quantity 2 squared plus quantity 2 squared. So we have it as 4 plus 4 is 8, or 2 square root of 2. So with that, we can now find the orthogonal projection of V on B using this formula. So we have here now projection of U, or rather this is now your V onto B. And that is, we have V dot B all over the magnitude of B squared times B, vector B. So we now have the dot product is 4 all over the magnitude, that is 2 squared of 2 squared times your vector B. We have the components 2, 2, 0. So with that, the projection now of V onto B would now be equal to, this gives us also 8. So this will cancel. So this will now be 2. So therefore, we have it as 2, 2, 0 over 2, where we can also write this as 1, 1, 0. So this is the projection of V onto B. And defining now the vector component of B orthogonal to B. So we have this as the formula. So we have here now, U will be denoted as our B. And then you have this as W1 is your projection of U onto V, or projection of V onto V. So with that, we now have V equal or minus W1, which is projection of V onto B, is equal to V is, we have it as 1, 1, 1, minus we have it as the projection of V onto B is 1, 1, 0. So we have 1 minus 1 is 0. 1 minus 1 is 0. Then 1 minus 0 is 1. So this is now the answer for the second question. Find the vector component of B orthogonal to B. And the other one, we have this as the orthogonal projection of B on B. We have this as the answer. So that is the lesson on vector projections. So we have here the answer on this slide. So let's compare my answer to the answer provided here. So the answer is in IJK notation. So let's us rewrite it using the angle bracket form. So this can also be written as, we have it as, for the projection of V onto B, that's 1, 1, 0, which is the same as my answer. Then for the vector component of B orthogonal to B, that is, we have this as K. So it's also written as 0, 0, 1 in bracket notation. So that's how we solve this problem here.